We're told that Homer is 18 today and that he wants to retire by the time he's 50. So that means he has 32 years until retirement. Homer wants to be able to withdraw $3,000 each month for as long as he lives once he closes his annuity at the time of retirement. Currently, he is earning an average of 8.05% compounded monthly. When he retires, he puts the balance into a safer, less volatile investment account that only earns 2% compounded monthly. This is a pretty typical thing to do. Usually, as you get closer to retirement, you want to make sure that there's less risk involved. In other words, if you have a really volatile investment where some of it's in stocks, then it could always collapse and you could actually lose money and not be able to retire, which is what happened to a lot of people back in 2008, 2009, and still, in fact. He does not make additional payments to the account after retirement. The question is, what accumulation of money should he have in his annuity at retirement for the above scenario to be possible? Keep in mind that in order to withdraw payments as long as he lives, he must live off interest alone. Okay, so at retirement, we know that he's going to be getting 2% compounded monthly. Now that's not good for us because we know that this is not what he actually gets paid monthly. So every month he'll actually get paid in terms of a decimal. We'll do percent. 2 divided by 12. He'll actually get paid about 0.167% per month. And so that translates to 0.00167 as a decimal. Okay, now if we take this percent, now remember he does not make additional payments. So whatever his balance is at that time, let's just call his balance B. Whatever it is at that time, once we take 0.00167 or 0.167% of that balance and we charge that back to the interest, that's going to be $3,000. That's what he wants to happen. Now that's going to be the case every month because every month he's going to withdraw that interest and he's going to use it to pay his bills, etc. So every month his balance is always the same. And thus, taking the constant percentage of a constant balance will produce a constant amount. This is a basic investment principle you want to really become comfortable with because this is really how one should think upon retiring. What's my rate going to be? What can I rely on? And what do I want to be able to withdraw every month? So to solve for the balance necessary at retirement, we just divide 3,000, solve this equation, divide it by 0.00167, and we get $1,796,407.19. Now you can do this with your own goals, depending on if you kind of do some market research, you can kind of figure out what low risk investments have been paying. Right now they're really, really bad, but in the future they could really shape up. So this is the balance required at retirement. So now we can use this to answer some questions. What would be his required monthly annuity payment for the accumulation of money to occur? So over 32 years, he's going to be making some type of payment. And that payment is going to be based on 32 times 12 months, which is 384 months total until retirement. Now, up until retirement, he's going to be earning this nice, beautiful percentage rate. That's what he's going to be getting on his annuity. As far as we know, nothing's put in initially. We don't know what his payment is. That's what we're trying to figure out. So we put in nothing initially. We're trying to figure out the payment. And we know that he wants to have this balance at retirement. So $1,796,407.19. So $407.19. So 1,796,407.19. Okay. And so now we need to calculate our payment. What would the payment have to be every month? And that payment would have to be $1,001.58. So that's actually still a very big amount for most people. But in order to accomplish this goal of getting that much, that's what he would have to put away every single month. Next we want to know how much would he have put in out of his pocket over the duration of his annuity. Well, we know that he's put in $1,001.58 every month. How many months did he do that for? 384. And so if you analyze the units on this, this is dollars per month. This is the number of months. So we end up with dollars when we multiply these together. So we'll do 1,001 and 58 cents times 384. So that means altogether, out of his pocket, he put in $384,606.72. That's what came out of his pocket. So that's relatively small compared to what he actually ended up with his balance. But then again, there's no free lunch. So you've got to make sure to put in a lot in order to get out a lot. How much interest will he have earned on this annuity? Well, that's just the difference between what he has at the end of the 32 years, and what he put in total over the course of those 32 years. So this is 1,796,407.19, and take away what he put in, which was $384,606.72. So we can do $1,796,407.19 minus the out of pocket 384,606.72, and we end up getting $1,411,800.47. So that's basically what he has earned in interest. So what we need to be able to do in order to accomplish that, in order to be able to accomplish that, is make this regular payment for this many months, and he will be able to accumulate his total balance, and he'll earn quite a bit of interest. Now, alternatively, the way you could do this is to calculate this last step here really quickly, if you do have a calculator handy, is to use the sum of interest button here. Under Apps, Finance, and then you have to scroll down to letter A. So the sum of interest, and we want to know the periods over which we want to add up the interest. So the months, which month to which month. Well, we start at month 1, that's when we start earning money, and we go all the way up to month 384. I would think about this in terms of the payment. So the first payment through the 384th payment, how much interest is earned, and you'll notice that that adds up to almost exactly what we have. We have $800.70. This is $799.99. This is a little bit more accurate because it's not rounding, but we're very, very close. We're within several cents of the final amount.